Hello and welcome to the Protecting Your Organization from Know Your Customer Data webinar from Everfox. Next slide, Alex, please. So I'm just going to run through the agenda and then we'll get into the meat of the content. So we are going to talk about the Know Your Customer sort of landscape and why you're all here. Then we're going to talk about problems in trying to defend against sophisticated and novel attacks, and how potentially adding prevention capabilities to your detection-based defenses can help in preventing those attacks. And I will do a demo just showing some of the methods that people are using to bypass existing defenses. And we'll talk about how you can then deploy a CDR type solution in your environment before going into a Q&A. Okay, thanks, Alex. Next slide. So by way of introduction, I am Humphrey Browning. I am the Global Solutions Sales Lead at Everfox for all of our sales outside of North America. And with me, I have Alex Tasker, who is pre-sales engineer. We both worked together over a number of years, talking about and evangelizing about our products. Okay, so let's talk a bit about the Know Your Customer landscape. We have quite a mixed audience here, made up of both sort of technical and non-technical people, and we'll try and keep this fairly high level. Please put any of the questions you might have into the chat, and we'll do our best to answer them either this afternoon or separately outside of the meeting. But we'll try and keep this pretty much non-technical, but hopefully it'll be of interest. So why are we concerned about sort of interactions with customers? No, everyone is doing it. Sort of government agencies, public and private sector companies, individual customers. We're all sort of working together to share information about who we are. Trying to transact with an organization, be that registering with a firm of lawyers or trying to apply for a mortgage with a bank. We all need to and are asked to regularly to share data with other organizations. And as part of that process, organizations are wanting to verify who you are, to make sure that they can authenticate the transactions that are taking place, so that they can perform the particular function that they're trying to undertake. And as part of that cycle, I guess, there's a sort of onboarding and verification process at the outset, and then some sort of continuous monitoring of your identity and who you are, making sure that someone isn't masquerading as you, and then making sure an organization is needing to make sure that they are compliant with whatever regulations they have sort of handling your data. And the problem in this particular landscape is that attackers are aware that this is an opportunity to infiltrate an organization by effectively hijacking the sharing of data and injecting malware into an organization, typically as part of an ongoing attack or campaign to get into an organization for whatever reasons. Okay, next slide, please, Alex. So what sort of attacks are we talking about here? So we're talking about sophisticated attacks that are becoming more and more easy to predicate, and the sort of things we're talking about are 0 days. So with the rise of artificial intelligence and machine learning, it's becoming easier and easier for threat actors to create new and novel attacks. And the sorts of attacks and the sorts of techniques they're using, are starting to sort of weaponize content. So something that might look benign, making it able to be malicious. And they're doing that in more and more sort of sneaky ways, if you like. So nesting attacks within other content. So multiple layers of content hiding the fact that there's an attack waiting to be launched. And they are doing this by manipulating the integrity of your files, or creating files for themselves. Maybe your files haven't been manipulated, but an attacker could be posing as a customer, trying to get into an organization, just so they can have that interaction and upload of content sanctioned by the organization they're trying to get into. And then the sorts of attacks that we're seeing that are really prevalent and at the heart of a lot of the ransomware attacks that we're seeing, are using techniques like creating polymorphic malware, which is malware that can exist in multiple states, and using something called steganography, which is basically encoding information in a covert way so that we can't see that the malware that they're trying to get in is actually in the object that they're sharing. And as we go through the demo today, we'll show you the polymorphic malware and how that works and how that can get past detection-based defenses and how we stop it. And the typical targets for these attackers and these types of attacks are any organization that has some IPR that is worth getting to, or has some data that someone wants to steal in some way, or indeed someone might just want to disrupt an organization. So it could be a government agency, it could be a private or public sector body, or it could just be a targeted individual that someone is trying to compromise by planting malware on their systems. Okay, so I'm going to hand over to Alex now to tell you a little bit more about the attacks and the nature of the attacks that we're seeing.
Yeah, so there's a sort of vast and complex landscape of bad actors out there, and organizations' infrastructures are typically relatively simple, and deploying conventional tools to protect these infrastructures against malware and malicious content really still presents quite a large attack surface. And with the increasingly complex supply chains, that attack surface really becomes unknowably large, and becomes ever easier for these bad actors to find novel attack vectors, as Humphrey has said. And if we try and keep track of the malicious content and reconnaissance attempts that are coming from all the untrusted sources that we have to interact with, that could be pretty expensive and not necessarily really worthwhile. It's just a fact. We know there will be attack vectors that we're unaware of, but bad actors are actually using. But because we're unaware of them, we can't detect them. And all the techniques and methods here really point to that first step of many advanced persistent threats, as we like to call them, in which user uploads like know your customer data give those bad actors a vector with which they can exploit some unrecognized vulnerability and gain an initial foothold in an organization. And today we're going to demonstrate a defense strategy against file-based malware in those customer uploads. Now, there's a number of headlines here that you'll probably recognize most of. And while these aren't all specifically about know your customer data exploits, they do sort of give us a window and show us a broad pattern of malicious actors exploiting flaws in conventional infrastructure and using uploaded data as that first step of getting that initial foothold. And as they're coming up with new ways all the time, we're illustrating here really, every case here was a zero-day attack which had been recently discovered. And of course, these are just the guys who got discovered. And so obviously there are many, let's say, attacks out there in the wild which are in use, not being detected yet. And so if we're relying on detection-based approaches, we're always going to be behind the curve. So how do we get ahead of that? Humphrey.
Thanks, Alex. Okay, so the problem is, as Alex has just been explaining, that with detection we only know what we know. The definition of a zero day is we haven't seen it before, And if we're trying to use sort of signature-based checking to spot something, then we need to be really, really good at keeping up to date. And if we're the unlucky organization that is being targeted with a 0-day, we are going to be behind the attacker. And the ability to create these types of attacks is really getting simpler and simpler. Where a few years ago we would have been saying it's a sophisticated attack from a nation state or some large entity. Nowadays, these attacks are being sold on the dark web, and they are being created by using AI and machine learning to morph existing attacks so they have a different signature and therefore become new 0 days. And so we're really struggling if we are relying on detection to try and stop these things. So the other issue here is that the attackers know where the holes are in our detection-based defenses. Whilst they might stop 98, 99% of attacks, it's that small percentage of opportunity that they're aware of, and so they're just bypassing the defense by focusing on the gap in the defense. And I guess the idea here is that if we need to take some sort of zero trust approach to the data, and we need to somehow change the game. And one of the techniques for changing the game is to move from a sort of detection-based approach to a transformation-based approach. And a lot of vendors have looked at this and started to use techniques whereby we are trying to sort of clean data and transform data, therefore stopping the malware. And that's certainly an approach that we at Everfox have taken to solve the problem. What I would say, and I'll say it again as we go along, is not all of the transformational approaches have removed the need for detection. And here at Everfox, we believe our approach is really giving us a way to keep and make sure that you have safe new files every time that you interact with a piece of content. Okay, so I'm going to stop talking about this and go and do a bit of a demo now. So by way of introduction to the demo, I'm sure if you were in social media and registering for this webinar, you'll have seen these pair of images. And the point here is they both look exactly the same, but one contains malware and one doesn't. And you have no way of knowing or detecting that. And I'll show you why that is in a second. So let me just share my screen. Alex, I think you have to allow me to.
I've just hit the button.
Thank you. There we go. This is allowing me to now share my screen. Okay, so let's have a look at some images. Just hopefully everyone can see that. Okay, so here I have 3 copies of that driving license image that I was showing before. One is completely clean. One has a script steganographically encoded across the pixels of the image, and another has a script embedded in the image file that means that the file could either be used as an image file, as it is being shown here, or if I were to rename it as an HTML file, which I've done here, it can run as an HTML file and run the script that's embedded in this file. So imagine in the Know Your Customer scenario, I'm uploading a copy of a driving license. It looks and feels exactly like a driving license to any detection-based technology, and I'll show you that in a second. But actually, it's got a script embedded in it, and that doesn't have to be a script. It could be any content at all, any binary content or any other content could be appended to this image, and therefore get into your organization without being detected. So I'll just open up this image file to show you my Windows image viewer shows you the image quite happily. If I were to just close that for a second and open it with Notepad now. So let me just open that with Notepad. You'll see that if I scroll down, here's all the image data in that image, but at the top of the image, there's a script. Yeah, just highlighting it for you there. So this is an example of something we call a polymorphic file. It's very easy, very trivial to create this type of file. But if I were to rename this file as an HTML file, which I've just done to save time beforehand, and now open the HTML file, you'll see that the script runs, and in this case, it's taken me to a demo site, which suggests you might have had all your files encrypted. I'm glad to say that they've not all been encrypted in this case, but I just want to illustrate the point that it's really easy to make a file that can exist in two different states. And the point here is that if I take that same file now and put it through VirusTotal, so if I go and take the image file I was just showing you and upload it to VirusTotal, you can see that there are 60-odd antivirus checkers in VirusTotal here that are saying there is nothing to detect in that file. The file I've just shown you, there was a script embedded in. And all the major vendors are here, and they're not detecting that particular type of attack. Actually, there's a whole load of sandboxes in VirusTotal as well, but none of the sandboxes run on image data. And again, that's a problem because now you're not going to have your sandbox stop this attack either. So the point here is that attackers know how to create these attacks. They know, they can embed executable content in these attacks, get that content into your organization, and then they can exploit that at a later phase of an attack. So how do we stop that, and what can we do to stop it? So if I take you to Everfox's Try Now facility, this is freely available for you to try. Tryitnow.everfox.com. You can upload a file here. We will transform the file for you, create you a brand new file, and then and remove any threat that's in that file. But the point here is that we're doing that without looking for the threat, and I'll explain that in a second. So let's just take that same file that we had a second ago, take the polymorphic file, copy it in there. Okay, so the file's been uploaded, and a new file has been created, and I can now download that file so that we can see the new file. So this is a brand new version of that image file that I've just created, and I'll show you in my downloads folder in a second. And what's happened here is that rather than try and detect the script in the file, the CDR software basically extracts the information from the image that it needs to create a new image. So we pull out the sort of pixel array here, we pull out the height and width information from the image, and then we verify we've got those things, and then if it verifies properly, we then build you a brand new image. So we've not looked for the script, we've just left the script behind because it shouldn't be there. And that's how we can defeat this type of attack without needing to detect it. So any new script, any new type of content, any erroneous content in this image data would just get left behind by our CDR process. I'll just show you that in my downloads folder. So here's the image, the new image that I downloaded. Again, I can open it, and you can see it displays perfectly happily. But this is brand new file, and if I look inside this file with Notepad, you can see that the script that I was showing you before, which was at the top of the file, has now gone. It's been left behind by that transformation process. The image data has been rewritten by us as part of that process too. So this is a really highly effective way of preventing attacks without trying to detect them. Now, the problem here is that the type of attack gets even worse. I've shown you a file where if I know what I'm doing, I can look inside the file and I can see the attack content in that file. Actually, attackers can encode the binary content or whatever content across the pixels of an image using this technique called steganography, and that makes it even harder to detect that sort of attack. And so we need to be able to stop that type of attack too. And in our transformation process, we can disrupt the pixels of the image as we transform the file, such that if anything were encoded across them, we would defeat that type of attack as well. So we're stopping these advanced threats through polymorphs and through steganographic files using the process of transformation. Okay, so I'm going to hand back to Alex now to talk about how we can deploy this on top of our detection-based defenses to increase the level of security you can get against this type of attack. I'll just hand back to you, Alex.
Thanks, Humphrey. You should be able to see my screen now, hopefully.
We can, yep.
We're good. So there are a number of different approaches to adding this CDR technology to existing defenses. And for this file upload type use case, there are still a number of different deployment modes, which I've detailed on this slide here. So first of all, we can integrate an appliance or a virtual appliance or a cloud service with a load balancer or a web gateway. And this enables us to transform an entire web request before it even reaches the web application servers. And the content within that request is subject to that transformation. Or we can actually integrate directly with application code. And again, this is either on-premise or in the cloud or even in a hybrid sort of environment. And we can deliver this service as an API that your application code can consume. Or we can actually sit in between that application layer and the back-end storage and deal with that data in transit between those different layers. And again, transform all that content, ensuring that what gets delivered is completely clean. And the most common deployment mode, however, is this first one that I mentioned, this ICAP integration with load balancing tools like F5LTM, for example. It's worth mentioning that these transformations, as you've seen in Humphrey's example, are extremely quick, and user experience is really unaffected. Typical business file type content that the know your customer use case really implies are all sub-second or typically milliseconds to take that initial uploaded content and create something clean from it. Because there's no database lookups going on, and there's no calls out to internet resources. This is always quick and always discreet.
Thanks, Alex.
And so I'll just flip over to a slide inviting questions.
Okay, let me have a look and see if we have any questions here. So there's a question here, Alex, about updates and how often we need to update a prevention-based defense using CDR like this one.
Well, this is a beautiful thing with this approach, actually, because we're not looking for signatures or behaviors that have been identified in the latest sort of variants. We're not sort of playing that catch-up game. We're really just using our own interpretation of specific file and content formats to create something safe rather than actually trying to detect anything malicious. And that means that our original software, actually created several years ago, is still protecting customers against threats that we don't even know about yet.
Gosh, that's amazing.
And those customers, I'll add, have never come to us with a piece of malware that has got through this technology. So yeah, no breaches that anybody has reported back to us, which is, again, a bold statement.
Another question here about embedded content and how we might handle embedded content. So we talked about sort of nested attacks at the beginning. Can you say something about how we would stop sort of these sort of a nested attack that was hidden in layers of plain content?
Sure. So one in an office file, for example, is a zip containing a number of embedded items, and we can nest items embedded in that even further. And this process will iterate through all those layers one at a time and apply that CDR process to each element of the file or the piece of content recursively in such a way that everything gets delivered clean.
Thank you.
I should add actually that, and this is something that sort of echoes some particularly well-known security attacks. If we have a piece of content masquerading as something which it's not, for example, a GIF file masquerading as a PDF, then that will be processed as a GIF file. And so if there's no GIF content, the PDF content will all get left behind and nothing will get delivered, just a little redaction message. And so we're very strongly protecting against that kind of approach to defeating malware protections on any kind of device.
Thanks, Alex. I've got one more question here, just in relation to sort of a KYC. So the question is around, do we think that AI or NLP and behavioral analytics are good solutions to improve your security beyond the CDR that addresses some huge attacks?
Yes, so in terms of detection, if you really want to know what's hitting your perimeter, so to speak, then yes, absolutely. But I would endorse an approach that ensures you're delivering clean content into your systems and your backends and your endpoints. And certainly people I've spoken to in the industry are much more concerned with delivering that content safely and keeping those processes running without incident than with actually detecting the attempts to ingest malicious content into the organization.
So one other, I think we've just about got time for, is every file logged and the resultant suspect code sent back to Everfox for additional analysis?
No, this is something that operates completely discreetly. If something's deployed on-prem, it can sit alongside a gateway or in line without requiring any connectivity to anything. And indeed, we don't try to compile any sort of threat database or reputational service. We're just delivering clean data based on the content that's input into this process.
Thank you, Alex. Okay, we're just on the hour now, and run out of time. There are another couple of questions that I will respond to privately, but thank you so much for attending. If you wanted to know more information, we have some other available resources you can download, and we'll share the slides with those that attended. Thank you so much for joining. Hopefully this was informative, but please feel free to reach out to Alex and I or any of our colleagues at Everfox to learn more and to discuss your particular environments. Thank you so much.
Thanks very much for attending.
Bye for now.